in this example, we're trying to identify some of the transformations that are happening to the absolute value function. So to start explaining this, what I want us to do is look at the general form, which looks like this. Now the a value is in charge of a lot of things, but I'm actually going to start with k and h because we aren't using those in this example. The k, when you add or subtract outside the grouping symbol, does a translation, and if it says plus k, it's going to go up, and if it says minus k, you're going to go down. The h, because it's addition and subtraction again, is also a translation, but because it's in the grouping symbol, it's going to be going to the left or to the right. So if it says minus h, you're going to go to the right, and if it says plus h, you're going to go to the left. Because of the minus that's in the equation, it feels like that translation's a little bit backwards. Now the a is in charge of three things, and all of them are vertical. Okay, so if a is a negative number, you're going to have a reflection. That means that the graph is going to flip upside down. If you ignore the minus sign that might be there, and the actual number for a is bigger than 1, you're going to stretch the graph vertically. And again, if you ignore the sign that's there, and you look at the value for a and it's less than 1, so it's like a fraction like 1/2 or 3/4, you're going to compress your graph vertically. So when I look at this example, I have an a value here because it's something being multiplied to the absolute value. Now because a is negative, I'm looking at a vertical reflection, which means that the graph is getting flipped upside down. And because the number itself, a 3, is bigger than 1, I'm looking at a stretch. So I need to pick the option that has a vertical reflection and a vertical stretch. So this first option mentions a vertical stretch, but it's not talking about the reflection. The graph of g is a reflection over the x-axis is also an option here, right? So both of these are great answers. So now here, having a vertical compression, that's not going to be true. And having a translation, nothing was added or subtracted, so that's not true either. So our comparison here, we have a vertical stretch and a reflection across the x-axis.